Okay. All right. Well, thank you all. I'm very excited to be here today. My name is Sara Nedrich, and I'm here to present Tires to Toxins, an update on 6PPD-quinone investigations in Michigan. Today, we're going to go over some new field data collected in Michigan, looking at 6PPD-quinone concentrations in surface water, as well as I'm going to overview a study we did looking at crumb rubber as a pavement type additive and looking at leaching of 6PPD-quinone from crumb rubber. And this is an update as I did present on this topic back in, I believe, 2022. So that link is here if you're interested to know more about the history of this research. So today I'm speaking solely in my individual capacity and not as a representative of my current employer, Dow, or previous employer, Eagle. So I did do all of this research, and it was funded entirely by Michigan Department of Environment, Great Lakes, and Energy, or Eagle. I currently am working at Dow. I just started in January. So that's just a heads up there. Our collaborator on this project was Michigan Tech University's Department of Engineering. All right, so a little bit of background. I was surprised to see I was the only talk on 6-PPD-quinone. This is a really important microplastic leachate that is actually from tire wear particles. And it's an oxidation product of 6-PPD, which is used on tires as an antioxidant coating. 6-PPD transforms in the environment and can be found in runoff, getting into surface water. And it's acutely toxic to salmonids in part per trillion quantities. There have been large fish kills observed out in the Pacific Northwest states, so it's a very hot topic out there. In the Midwest, usually the fish kills we see have more so been tied to issues with temperature or siltation. They have somewhat been tied to urbanization, so it's possible that 6-PPD-Q is an unknown variable that just hasn't been studied. And then the seminal paper on this topic, if you want to learn more, is Tian et al. 2021, which was published in Science. So I wanted to just emphasize again how toxic this is. It is acutely toxic, so that means within a very short period of time of exposure, you can have 50% to 100% mortality. If you look at these numbers here, they're in the part per trillion. The most sensitive Great Lakes species we have is coho salmon. They're not the most common salmonid in the Great Lakes. The more common species is like rainbow trout or brook trout. And then the most recent research did find also that it's toxic to lake trout. If we were to currently develop acute maximum value in Michigan, which this isn't published, but this is what it would look like. It'd be about 6.6 nanograms per liter, which is just above the detection limit for 6-PPD-Q. So very toxic. All right, so I'm going to go right into data. I wanted to present some surface water sampling we conducted in Grand Rapids, Michigan. So this is the Grand River. Let's see. Oh, yes, I can use my pointer here. So we have two locations that I'm sharing data for. One is a smaller tributary called Indian Mill Creek that is actually upstream of this location, which is the Grand River. And this is in a very urban area. So there's roads that are just running very close to the river in this area. And there's a major highway that goes through it. So this is a prime location for where we would expect to see 6-PPD-Q. These samples were taken from an auto sampler doing 4-hour composites, and we were able to capture a 2.1-inch precipitation event. So you can see on the x-axis here, it's time after precipitation begins. And we got peaks of up to 19 nanograms per liter in both locations. Keep in mind, this is a composite sample, so that's sort of an average over 4 hours, wherein the ultimate peak could have been much higher. One thing we found really interesting in terms of timing sampling is that the tributary peaked a lot earlier, about 4 hours into the storm event, whereas the larger river peaked about 12 hours in. So there's really hydrologic variability in terms of when you can see that peak. And then we also saw exceedances of this acute value. So that 6.6 nanograms that I said, that would be the acute value. So there is potential risk for impacts to salmonids based off that number. Okay, and now I'm going to kind of shift gears and talk about our tire reuse project. We had a few objectives we were really hoping to address. In the state of Michigan, we actually provide grants to help develop technologies that use tires as a recycled product. And one of those is in roadways. So we wanted to understand if crumb rubber roads have increased leaching of 6-PPD-Q or if it's similar to a traditional asphalt. So that's what we were evaluating. We were able to partner with Michigan Tech University, who does road testing of different road surfaces. That was great. We compared field collected runoff to lab-based leachate, a lab-based leachate simulation. And we were also looking at road aging. So we collected 1 year after another. So we had a 2-year sampling period in the field. And then we did a 3-hour or 3-year simulation in the lab as well. So we collected runoff from 4 different test strips. Our control was a traditional asphalt road. And these were all constructed the first year we sampled. So it was 2022. The design for the test road included 3 different overlays. We had a traditional asphalt overlay, rubber modified overlay, and rubber with TOR. TOR is an additive that helps with it helps the surface of the road absorb water better. So those were the 3 overlays, and the 3 test strips were also underlaid with this rubber chip seal. And we collected runoff using this bottle trap method. This was submerged about 1 foot underneath the ground and then collected through the funnel. We collected surface water as well from 2 water bodies upstream and downstream of the rubber modified overlay section. And then our leaching test was using SPLP, synthetic precipitate leaching procedure, and we looked at aged and non-aged samples. Our results for surface water, we didn't see any detections of 6-PPD-quinone. These were one-time grab samples, not auto samplers, but they were collected within what we would expect to be the window of 12 to 24 hours after the storm event. Our runoff results, when I first got them, were very confusing. We saw that the 2 rubber modified overlays had very different results, but there was consistency between years. So aging didn't seem like it had too much of an effect, at least within 1 year. And then you see the 2 asphalt overlays having very different results as well. So we had to kind of think and put our brains together. And one thing that we did find to be an important variable in this, actually driving this relationship more so than anything, was the distance from an intersection. So the 2 sites with the 29 nanograms per liter runoff of 6-PPD-Q were actually quite close to corners, where if you think about it, traffic is stopping and then turning, and that's going to lead to more tire wear particle shedding. So we actually think in this case, it was actually the cars driving on the road and their behavior that was driving differences in runoff and not the specific road layers. And this is consistent with other studies that have been published as well. So then, of course, I have my laughing woman here because field and lab results, they never make sense when you pair them together. I don't know why we keep doing it. But we saw that our lab results of the leaching tests were very different than what was happening in the field. So we actually saw leaching of 6-PPD-quinone from the rubber modified, and of course, nothing from the asphalt because it doesn't have any. So we kind of determined that this SPLP method is not a realistic test for determining beneficial use of recycled products, particularly for this specific analyte. The SPLP test, it's really like you take a asphalt sample, right, which is you have to kind of melt like it in the jar, and then they react it with sulfuric acid, like water mixture to represent acid rain. So it's got like a little bit of an acidicness to it. And then it's rolled for 24 hours. And then they extract that water. So it's sort of like the road being melted and then flooded for 24 hours, which, when would that really happen? So it didn't seem like a reasonable test to compare what's actually happening in the environment. And then we also wanted to emphasize too the benefit of using rubber chip seal in roads. A lot of engineering studies have shown that it prevents cracking, especially in cold climates like Michigan, where you have the freeze-thaw cycles each year. So there are other benefits to having rubber in roads. Our overall summary and findings are that we found no evidence suggesting rubber-modified pavements led to an increased runoff of 6-PPD-quinone. Intersections and road stretches with increased tire wear particle shedding may be associated with increased 6-PPD-Q runoff. We found that SPLP likely overestimates leaching of 6-PPD-Q from rubber-modified asphalt and shouldn't be used exclusively for beneficial reuse determinations. And then we found that 1 to 3 years of aging did not significantly impact 6-PPD-Q release. We think this is probably because the tires are already aged. These are recycled tires. They've already been used. So a lot of that 6-PPD is probably already broken down. So I wanted to highlight some additional watersheds that I really feel need to be analyzed within Michigan. I have the Grand River in here again, just because I believe there needs to be some additional sampling over time, as opposed to just a one-time storm event. And then actually in the Clinton watershed, they have declining populations of cold water salmonids, particularly brook trout. So there needs to be some additional studies there to make sure 6-PPD-Q is not a driver. And then these are 2 other really highly urban watersheds that should be studied as well. And 6-PPD-Q is just kind of an unknown space in terms of all the science that still needs done. So I just kind of listed a whole bunch of things here. Not that I'm going to go into all of them, but there is a lot of research still needing done. Okay, and that's it. Thank you so much for listening, and feel free to reach out with any questions or to talk more about these types of issues.
Yeah,
thank you.
Presenting. We have time for 1 or 2.
We have a question in the Zoom. The first one is, for the concentrations measured after rainfall events, where was the sampler placed, and did you just use one?
Very good question. Yeah, so we it's kind of hard to explain. We did use 3 to 5 replicates per road section. And it was kind of challenging. In our first round, we actually analyzed for a whole slew of different things. So I needed like 3 liters of water. And in that one, I did a composite sample. So I combined from 3, which led to no replicates at the end, right? It was just a composite for the 6-PPD-Q. In my 2020, my next year of sampling, I learned better because I needed to do statistics. So I did 3 separate reps and then combined them for each test strip. And the bottle traps were placed. So there was the road, and then there was like a little bit of gravel usually, which is, required for roads. And the filter was put right at the end of the gravel area, and dug so that it was like maybe an inch under, so that it would capture the runoff. It was really important with the bottle traps to get a very large storm event. So they're not very good at if you have like a smaller, like a 0.3 inch event, because you don't get that sheet flow. So I really needed sheet flow to collect runoff. So that's one, like, I don't know, one negative thing of the method that I used, but
So we are
oh, mhm. Yeah.
we are out of time for questions.